Hi there and welcome to Hegarty Maths. It's Mr. Arnold here and this is the fourth video on sequences, and in this video we're going to focus on sum notation and some problems in context. Now this video is mainly aimed at A-level maths but is applicable to lots of other maths modules, so hopefully you find this useful. Okay, in the last video we did a quick proof where I showed that the sum of a series is found by doing, I'll just write this down, so S of n is equal to n over 2 times by 2a plus n minus 1 times d. And if we use this formula, that will find out the sum of a series. I also said, and we did that proof, I also said that we can actually find the sum of a series by doing n over 2 times a plus l, where l is the last term. Now I didn't actually show how that proof can be found. Now it's fairly straightforward. If you think of a sequence, so we start with the first term, a, the second term is going to be a plus d, the third term will be a plus 2d, and the sequence continues on, and the final term is going to be, a plus n minus 1 lots of d. So the important thing is that the last term is this. So what I'm going to do is I'm going to let L be equal to a plus n minus 1 times d, and I'm going to substitute a plus n minus 1 times d in here. So if we take what we already know, S of n is going to equal n over 2 times a, and I'm substituting this part in black. So instead of L, I'm going to write plus a plus n minus 1 times d. And let's tidy that up. So we get n over 2 times a plus a is 2a plus n minus 1 times d. So if we can prove the first one here in blue, and we know that the last term of a sequence is given by this formula here, we can substitute that into this and easily prove that the sum of a series can be found by doing n over 2 times a plus l. Okay, now sum notation. So lazy mathematicians is what I have here. And let me just explain what I mean by lazy mathematicians. We're very good at finding quick ways of writing down things that often take a long time. So rather than saying add up all the values for this function here, not function, that's the wrong word. In fact, what I will do is I will write out this this series here, and then I'll explain how we've made it nice and quick. So if I take 1 and I put it into this, so 2 times 1 plus 3 is 5, and then I'm going to add to that the next one after this. So I'm going to increase this value by 1, so r is now going to be equal to 2. So I'm going to do 2 times 2 is 4, 4 plus 3 is 7. Then I'm going to increase it again to 3. So I'm going to do r equals 3 now. 2 times 3 is 6. 6 plus 3 is 9. Then I'm going to do 4. So r equals 4 now. 2 times 4 is 8. 8 plus 3 is 11. And then do r equal to 5. 2 times 5 is 10. 10 plus 3 is 13. So rather than say add up all the values 5, 7, 9, 11 and 13, we're actually getting that from this notation here. This symbol is the Greek symbol sigma, or the Greek letter sigma, and it means it's a short way for a mathematician to say add up. And the values below and above are increments. So it tells me to start when r is equal to 1, put it into this, then add, then increase r to 2, put it into this, add, r equal to 3, and so on and so forth. And we're going to stop at this number here. If you've done statistics, you should be familiar with this because we actually use this symbol to work out the mean. Let's have a look at this one here. Again, we can use some notation instead of writing out the whole series. So I'm going to put 1 in, do 18 take away 3, which is going to give me 15. Increase the value of r by 1, so r is now going to be 2. 18 take away 2 lots of 3. So 18 take away 6 is going to be 12. The next value is going to be 9, then 6, then 3. And I'm going to have to keep going. I need 9 values, so from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and just going on to the last line here, 9. And I could add up all these values. So this is just a shorthand way to write down this series. Okay, so let's have a look at this. It tells me that the sum from 1 to some value n of this is equal to 720, and we're asked to find the value of n. Now remember, the sum s of n can be found in 2 ways. We can do n over 2. In fact, from now on, I'm not going to write n over 2 because I don't particularly like that way to write it. I'm going to write it as a half times n times 2a plus n minus 1 times d. Or another way was to write it as n over 2, which I'll write as a half n times a plus l. So they're the 2 formula we should be familiar with. And what I'm going to do is, I know that if I add up this series, I should get 720. So if I add up this series and I stop at the nth value, it should be equal to 720. Now I'm asked to find the value of n. There's 2 ways we might go about this. I'm going to actually use this formula here. So let's see how we might do that. I need the first term, a, of this. I need the first term, a, of this series. So what is the first term? It's going to be when r equals 1. So a will equal 4 times 1 take away 6. 4 times 1, which is negative 2 altogether. That's the first term. The last term is going to be found out by putting in n. So I'm going to get L is going to equal 4 times n subtract 6. Let's see now if I can substitute this value of a and this value of L into here and solve an equation. Okay, so I know that a half times n, or n over 2 as you might see it, times a, which we've worked out to be negative 2, plus L, which we've worked out to be 4n minus 6, must be equal to 720, because that's what we were told. Okay, I'm going to multiply everything by 2 now because I don't like a half n, so I'm going to make this nice and easy now. N times, I can combine this negative 2 and negative 6, so we get 4n minus 8 must equal 2 lots of 720, 1440. Okay, what else can we do here? I can see in this here, and this is a fairly useful step. In this expression here, 4n minus 8, I can actually factor out 4. I'm going to factor out a 4. So I get 4n times n minus 2 must equal 1440. And that makes life a little bit easier because I can now divide everything by 4. So n times n minus 2 is going to be equal to, now I'm going to have to do a little bit of long division here. I'm going to get 3, 8, and a 5, 385. Okay, now the next thing that we're going to do is I'm going to expand this expression, so I get n squared minus 2n is going to equal 385. You can see where this is going now. N squared minus 2n minus 385 must be equal to 0. Just noticed a slight error. It shouldn't be 385. It should be 360. 360, and that must be minus 360. Okay, and now I'm going to have to factorize this. So I'm going to have n and n going to be equal to 0. And a careful bit of thought here. So factors of 360 that we can add to negative 2. Minus 20 and plus 18, I think. Which implies that n must be equal to 20 or n must be equal to negative 18. Now, obviously we know that we can't have a negative 18th term, so it's not this one. That's not the answer we're looking for. It's 20. So if we add up the first 20 terms of this series, we're going to get 720. Okay, let's have a look now at a problem in context. So Ahmed begins making annual payments into a savings scheme. He pays 500 in the first year. So the first term is going to be 500. And the amount he pays in increases by £40 each year. So if it's increasing by £40 each year, that means the common difference, D, must be 40. Find the amount that Ahmed pays into the scheme in the 8th year. Well, I would like to know what the nth term of this sequence is. Now we could use the formula A plus n minus 1 times D. So this is part A here, which is going to equal A, the first term is 500. N, the number of, the amount of terms, is the 8th year, so it's 8 take away 1, which is going to be 7 times, and D is 40. So we get 500 plus 7 lots of 40, which is 280, which gives us grand total £780. So in year number 8, he's paying in £780. Now the next part, it says that show during the first n years Ahmed pays in a total amount. This is important. The total amount in pounds is going to be this. So what we need to do is work out the sum of the series for n years and show that it's equal to 20n times n plus 24. So we're looking for S of n. the sum of the numbers, the sum of the series. And that's going to be equal to a half n times a plus, not a, 2a should I say, times n minus 1 times d. So we're just writing down the formula now, and let's plug in the values. We don't know what n is, so I'm going to leave it as a half n. A we've worked out to be 500, so it's 2 times 500 plus n minus 1 times d, which we've worked out to be 40. Okay, so now what we could do is try and make this expression here look like this. That's what we're heading towards. We're looking for 20n. I'll just write it over here on the side so we can see where we're going. 20n times n plus 24, I think. 20n plus, yeah, times n plus 24. Okay, lovely. So, 2 lots of 500 is 1,000, plus 40 times n is 40n. 40 times negative 1, negative 40. Okay, so we still have a half n times, and then tidying this up, 1,000 take away 40 is 960 plus 40n. I can multiply that half in, so multiplying everything by a half. Half of 960 is 480 plus 20n. And then finally, the very last stage is to see if there's a common factor of this expression here. The common factor in this case is 20. So factor out 20, we get 20n. Factoring 20 out of this, and we get 24 plus n. Now let's have a quick look. Hopefully you can see that 24 plus n is actually the same as n plus 24, so that worked out nicely for us, and hence we've shown what we were asked to show. Okay, let's see what happens next. Carol starts making payments into a similar scheme at the same time as Ahmed. She pays in £400 in the first year. So A for this person is going to be £400, with the amount increasing by £60 each year. So D is £60 for Carol. By forming and solving a suitable equation, find the number of years of paying into the schemes after which Carol and Ahmed will have paid in the same amount in total. Okay, so what we're going to have to do here now is actually work out, well, what would the sum of Carol's series be like. So A is 400 and D is 60. So this is part C now. A equals 400 and D equals 60. Let's work out an expression for the sum of the series for Carol. So it's going to be found by doing a half times n to 2a, so 2 times a, 2 times 400 is 800. We're going to do this slightly quicker, plus n minus 1 times d, d is 60. Okay. Right, I'm going to multiply this half in straight away. Make the numbers a bit more manageable. So I get n times 400 plus 30 times n minus 1 equals n times 400 plus 30n minus 30, which is going to equal n into 400 take away 30 is going to be 370 plus 30n. Again, look for a common factor here. Highest common factor I can think of is 10. So I'm going to factor out 10. So we get 10n equal 10n times 37 plus 3n. Okay, I think that's the best I can do with that series there, the sum of the series. Now the question is, by forming and solving a suitable equation, find the number of years. So this is, we're looking for the value n of paying into the schemes after which Carol and Ahmed will have paid in the same amount in total. So essentially, I want to know when does the two series equal each other. So what we're going to do is we're going to let Carol's series be equal to Ahmed's 20n times 24 plus n. 20n times 24 plus n, or n plus 24. Okay, fantastic. We're going to try and solve this equation now. So I'm going to divide both sides by 10n. So I get 3n plus 37. So I'll just swap these around. Addition is commutative. Nice, we can do that. Dividing this side by 2n, by 10n, we're going to get 2. And what's left in the brackets is n plus 24. So we get 3n plus 37 equals 2n plus 48. And now what we're going to do is take 2n off both sides. So we get n equals, and I'm also going to take 37 off both sides. 48, take away 37 is going to be 11. So after 11 years, both Carol and Ahmed will both have the same in their account. Okay, I'm going to stop there. Hopefully you found it useful. I'll be back again with another video soon. All the best with the revision, and take it easy.